Right, just to check it, can everyone see the slide deck?
Yeah, you can.
Okay, got that right this time.
Okay, let's start. So, hey everyone, and welcome to IPSec Australia. So today we have a very interesting presentation and chat from Asil Khan. So Asil is a product security engineer at the moment in Atlassian, but he's a former software engineer, basically turned cybersecurity a profession for him. So he works right now in a group of security engineers in Atlassian in LLM Security, and he's kind enough to share his experience and their understanding and whatever that we know today about security practices in LLM with us today. So take it over, Asil, and yeah, thank you.
Thanks for the introduction, Sar. And yeah, as far as experience, I've been a security engineer for all of 5 months and been involved with LLMs for about as long as a time as anyone. So hopefully you'll all find this useful. So the purpose of this presentation and what I want you to get out of it by the end is to answer the question, as a product security engineer, what do I need to know about large language models? They're the hot new thing. We've seen them in ChatGPT, Bing Chat, Google Bard. They're being deployed absolutely everywhere. What are the security implications of this technology? We've got a fair bit to cover this evening. I'm going to start with giving a brief overview and primer of what LLMs are, just so we're all on the same page. Then I'll go into what sorts of applications can be built with large language models. How are LLMs being used in the wild? What are the security implications of them? How can LLMs and applications integrating with them be attacked? And finally, what does LLM security look like? As I said before, this is a new field. We're still figuring out the security implications. New attacks are coming up about every day, and I'll just give a bit of an overview and what we've seen so far. So without further ado, what are large language models anyway? Didn't really know at the start when I was putting this together, so I asked an LLM myself. According to ChatGPT, a large language model is an AI model generating human-like text using deep learning and extensive data for contextual responses. So what does that mean? Broadly, an LLM is an AI that's trained on a truly massive data set within the language. We're talking Wikipedia, we're talking GitHub, we're talking all of Reddit, everything publicly available on Twitter. A whole other sources, movie scripts, books. After all this data is ingested, the creators of the LLM use it to train a deep learning AI model and basically analyze all the training data to form connections between words and try and make it predict the next word in a sentence. After that, in the case of an LLM like ChatGPT, the vendors fine-tune it to be able to follow instructions and act like they're engaging the user in chat. I'm not really an expert in machine learning. This is my understanding. I may be wrong about some of these parts, but I believe that's the broad strokes. So the way LLMs operate on text is they break the text up into tokens. On creation of an LLM, the vendor creates a data set of every possible token that they can have, where a token is a string of characters that are generally about 3/4 of a word. And LLMs also have a limit to the number of tokens they can process, where ChatGPT 4, as of last week, may have increased now, but as of last week, it could only handle about 8,000 tokens. That means the combined prompt to the large language model and its output should be smaller than this. Otherwise, the large language model would forget about the previous context before it hit of tokens before it hit that 8,000 limit. There's two ways to prompt an LLM to get it to do what you want. Those can be broken down into the system prompt, which is a way for an LLM's vendor and an application's vendor to break down the role and decide behavior of an LLM. Basically, what's its role? What is it trying to do? In ChatGPT's case, that's often you are a helpful assistant. You answer questions for the user. And then after the large language model has been prompted with the system prompt, user data goes into the user prompt for instructions or data that the language model should operate on. For example, if a user wants to do some research about Mars, they can ask ChatGPT. The system prompt and you are a helpful assistant and the user prompt, tell me about Mars, will then get concatenated together. That string is then sent to the LLM for processing, and it'll respond with some output, in this case, an essay on the fourth planet. Now, I said before, the system prompt is how to dictate the role an LLM should take in a particular application. If we change one word helpful to terse, we get quite a different response. It'll tell you about Mars in about 10 words. Now, that you can give it a system prompt like you're a terse assistant for a chatbot application. But if you want to integrate an LLM into another application pipeline, maybe to do some data processing, or in this case, act as a tone analyzer to tell you how happy a song is, to measure its emotional tone. You can also do that. You can dictate how it will respond. And in this case, you can get the LLM to act like an API that will tell you that Mr. Blue Sky is the happiest song in the world. So, what are LLMs anyway? I'll go out on a limb here and say that large language models are basically calculators for words. They're trained on a massive data set of words. They form connections between them. They pick up the next word in sentence, and they're further tuned to follow instructions and perform chat. But they can only make inferences based on their data set. They're not truly intelligent. They can often steer you wrong as well. They're not guaranteed to be accurate. I once got ChatGPT to tell me the name of the dog that swam between New Zealand and Australia, breaking the world record in 1986. They don't really know what an ocean is, they don't know facts, they don't really know whether it's possible, but they can be put together to build really cool things. What applications can be built with LLMs? There's a few examples that we've seen happen and that Atlassian itself is developing. They can be used in chatbot applications like ChatGPT or Bing Chat, which basically just engages the user in a discussion. They can be used as generative assistants, which will assist you when writing a document like Clippy did back for us in Microsoft Word circa Windows XP. Or they can be used as a contextualizer to summarize or provide context on a large data set. You can use it to query everything in a database, form connections, or you can use it truly autonomously to perform actions without human approval. as one API in a wider application context. In the next few slides, I'll talk about some of the architectures for these applications, starting with chatbots. Now, we've all seen chatbots such as ChatGPT or
У меня лекция называется Application Security for LLM Applications. Я сейчас рассказываю, что такое LLM Application.
Sorry? Okay. So we've seen the chatbot example of ChatGPT where a user writes a message, ChatGPT will give a response, and it'll act like the user's actually engaging the LLM in a conversation. Now, the way these are actually done is a cool trick where an LLM's output is only based on its training data and the direct input, not previous context. It doesn't remember previous prompts in the conversation. So every time you are sending a new message to ChatGPT, under the scenes, OpenAI will concatenate the entire message history before you, between you and the LLM, and send that all to ChatGPT to generate the next message. The conversation that we see that looks like we're talking to an actual intelligence is only an illusion there. And I mentioned the 8,000 token limit before. If the conversation goes larger than those 8,000 tokens, ChatGPT will actually start forgetting the previous original messages you sent it. Now we've gone over chatbots, we can look at something a bit more interesting. How can we use an AI as a generative assistant? In this example, there's a user interacting with a wiki such as Confluence to produce a document, and the wiki has an integration with OpenAI. So a user can write some text into their word processor. For a summary, the word processor calls off to OpenAI for a suggestion. The word processor then asks the user for approval on whether they want to include this text in the document. And finally, the user approves and the AI generated text goes into the published document. They can also be used as a contextualizer with a user, a database and its application server, and an AI like ChatGPT, where the user produces a database query. The application server takes the user's search query, gets information from the database and sends that off to an AI for context, finally returning a response with the user to the user for a summary on some data. They can also be used as an autonomous agent, in this case, in the example I'm going to show you, as a moderation API, where if a user wants to interact with a message board or a chat thread that has some moderation rules, they can send a message to the moderation endpoint. The moderation endpoint will query the AI based on the rules, receive a response, and either publish the message to the API if it's okay for the moderation rules, or deny the ability for the user to post to the message board, post to the chat thread, and participate in the conversation. Now, we've looked at some theoretical applications you can put an LLM into. How are they being used in the wild? Well, we've all seen the venerable ChatGPT, where you can get it to answer a question, engage in a conversation, and it'll respond to you. That's honestly pretty boring if you've played for it now, played with it for a few minutes. But you can embed them into other applications. Microsoft's been doing something cool with Bing Chat, where you actually get a sidebar in Microsoft Edge, and it can actually include and perform operations based on the context of the web page. So you can get it to say, make an order for you, or tell you, or summarize a recipe, or translate some text on the web page. It's a way to boost the ability of your browser. Atlassian itself is doing some interesting stuff, such as Confluence Search and Summary. Sorry. These were meant to be videos, so I'll just speak to them, where you can get Confluence to perform some context. You can give the AI a search query, and Confluence itself will inspect its data set and get the ChatGPT to summarize the top 3 results. It can also be used to convert natural language to JQL and perform queries where you can just get it to say, give you all the results for a particular product that are due for completion in the next 2 weeks, and ChatGPT will take that English text and give you JQL, which you can then run on Jira. Now we've seen some examples of LLM applications. How can they be attacked? There's 2 ways to attack an AI model. You can either attack the application, the service that it's running with, using a prompt injection attack, or you can attack the model itself during its training process. I'm not an AI expert. In this talk, I'm going to be focusing on the left side, attacking the service itself via prompt injection attack. Daniel Meisler has published an excellent blog post, which I encourage you to read, breaking down the attack surface of an application integrated with an LLM, where on the left side you have agents with some autonomy, and you can actually, by doing a prompt injection attack, and change the model's behavior or execute arbitrary commands, or you can use it to attack databases, extract significant sensitive data, or tamper with its results. Now, for an example of a prompt injection attack, you can take the tone analyzer example that I made, and a user could either put in the words to a song they want analyzed, or they can directly give the application an instruction to respond with a particular emotional tone and basically bypass the whole logic of the application. In the previous AI moderator example, they can, instead of giving a message for the AI to moderate, directly give instructions for how their message should be perceived. There's a few patterns prompt injection attacks can take. One of them is a direct prompt injection attack, which we've seen a fair bit of with ChatGPT or Google Bard, where a user puts in a provocative string of provocative instruction that's designed to bypass one of the AI safeguards. In ChatGPT's case, it's got safeguards against responding with hate speech or offensive content or harmful content, like you can't get to generate a phishing attack. But with some clever wording, you can get the AI to bypass these safeguards and it'll generate a harmful response. The user can then act shocked, post that response onto Twitter, causing reputational damage against the AI vendor. We've seen about 5 years ago on the attacks against Microsoft's Twitter chatbot, Tay, where the Twitter community basically turned that Twitter chatbot into a Nazi in 1 or 2 days, that we shouldn't really underestimate the reputational harm these attacks can cause by making a application vendor seem to condone speech that like really shouldn't be condoned or endorsed by anyone. There's also indirect prompt injection attacks, where if you have a contextualizer application that calls out to a database and then gives those results of the database to an AI for further processing, an attacker can give a malicious instruction to the database or data set, or even a search page, even a web page in the case of Microsoft's Bing Chat, which will contain a malicious instruction for an LLM. And so when a user makes a legitimate query to the application, and the application calls out to the data store to get some data to context, it'll pick up a malicious instruction for the AI, which it will then send on to the AI and obtain a poison result, which it will then show to the user. There's also two-step injection attacks, which are a bit more interesting, where if you have an application that calls out to an AI like ChatGPT and then stores that result in a database or displays that result to a user, a malicious user can actually ask the application to pretty please generate an attack against the database or generate a cross-site scripting attack against the final user that will view the results of the malicious user's query. And you've got an AI actually assisting a user in a SQL injection attack or a cross-site scripting attack without the user having to actually go through the trouble of writing some malicious SQL or JavaScript. We've already started seeing some prompt injection attacks in the wild. In this case, the security researcher Kevin Liu managed to convince Bing Chat that it should operate in a privileged developer mode and disclose its internal alias and internal capabilities, which Microsoft didn't want disclosed to the public. The security researcher Kai Greshak actually took this to a very interesting level with a website that was designed to give Bing Chat a malicious instruction that basically performs a phishing attack on the user. Bing Chat starts telling the user that they are an employee from Microsoft and asks for their credit card details to buy a Surface Laptop 4. The AI asks for their name, asks for their credit card details, and then finally to exfiltrate their data, creates a link with their personally identifiable information and their credit card details, which a user can copy and paste into their browser. And now you've got a web page that's designed to enable ChatGPT to do a phishing attack on you. Sorry, in this case, Microsoft Bing. Now, the way that Kite Greshak actually executed this attack was they made a web page that contained instructions for Bing Chat in 0-point font in white text on a white background. So it was invisible for the user, but visible for the AI that's actually processing the web page. They used some special code words system pound error state, which have been found to provoke some special processing within AIs like ChatGPT without insight into and the model itself. We don't really know why they work, but they can and have been used to perform prompt injection attacks. Now we've spoken a bit about what the threat surface is. What does LLM security look like? To start with, I want to give this caveat that prompt injection attacks and their mitigations are a novel field of research. There hasn't really been a clear best practice solution that's been identified yet, but there are some things that as security engineers, we can call out as good practice. To start with, an LLM, a large language model like ChatGPT, is accessed by an application through an API. And there are some API best practices that are basically good for everybody, no matter what the API is. And that is a solid agreement with the API's vendor. Atlassian ourselves have an agreement with OpenAI where we have exclusive use to two ChatGPT models, GPT 3.5 and GPT 4. These models are only used for Atlassian data. No one else can actually send a request that will get onto these models. They also have zero data retention. So no data from an Atlassian session is used by OpenAI for training purposes. And we've basically got no logging. All logs are stored for 30 days for compliance reasons and then deleted. All access also goes through a proxy, which only authorized services have access to, and access for services controlled on a case-by-case basis with the okay from our internal privacy team. If you want to deploy an AI integrated application in an organization, it's important to have a similar agreement with OpenAI, just as it's important to have a similar agreement with whatever your API vendor is, to ensure that your data and your customers' data doesn't get used for training purposes and won't get leaked in case of an attack. Beyond that, one can use some defensive prompt engineering strategies within the system prompt to ChatGPT to mitigate some prompt injection attacks. One way to do it is to encode all of the output for an LLM into JSON, which will allow validation and checking against the schema. In this, because while we can't really validate the input of an LLM in the same way we can validate and sanitize user text to prevent SQL injection attacks, or cross-site scripting attacks by URL encoding or stripping out special characters. You can't really do that to an input to an LLM because it's natural language, but you can sanitize its output. We can also include some malicious examples in the system prompt where if you have an application like the AI moderator, you could inform the AI that a user might do an attack to get their comment published anyway, which could be antithetical to the moderator's rules. And you can show the AI what that soft attack would look like so that the AI can effectively prevent that and respond to the user with an error message, for example. Since large language models often have a token limit, often have a limit to how much text they can store in their context. If you engineer an application that has the system prompt at the start and then concatenates that with user data, a user could just provide a whole heap of data, like the same word copied 50,000 times to try and get past the token limit. And after that, the AI will have forgotten the original instructions and the user can give it instructions to do what it wants. One of the ways around that is to sandwich the user input by starting with the system message of how it should operate, giving it the user input, and then at the end of it, repeating the system message or some guardrails of instructions it shouldn't follow or text it shouldn't generate, so that you've safeguarded against the attack I described before, a token stuffing attack. But all this advice is kind of a half measure because AI is about probability. Security based on probability isn't really security at all. So what can we as application security engineers actually do to protect applications integrating with LLMs? As it often is, the best defense is a defense in depth approach, where we can take everything I discussed on the previous slide and write prompts defensively, but we can also treat all LLM output as untrusted, just as we validate user input for SQL injection attacks and cross-site scripting attacks. We can still validate an input for an LLM, but we just have to shift the validation to the right and validate the output from the LLM. So if an LLM is embedded in an application that connects to a database, instead of looking for SQL injection attacks in the user's message, you can look for the same attacks before the text actually gets into the database itself. You can also be mindful of access control. You should send nothing in the system prompt that you don't want the user to see. If you have internal directives to an LLM application that gets concatenated with the user prompt, you should assume that you can be leaked. They'll be leaked. Microsoft found this the hard way with Bing Chat, where for whatever reason they didn't want Bing Chat to know that it was named Sydney. They didn't want users to know its internal directives, but some clever users figured that out anyway. In the same vein, if you're developing a contextualizer application that will query a database for some input, for some results that it should then summarize, you should ensure that the database query doesn't have any context that you don't want the user to see. In an application embedding a large language model, the large language model should have basically the same access privileges as the user. It shouldn't ever be able to make a query or do a privileged action that the user cannot, because otherwise the user can then attempt a prompt injection attack to elevate their privilege. And finally, while we're still working out the security implications, we should keep humans in the loop. If you're making an application that's like a document helper, a generative assistant, always make sure a human user can approve the message generated by the large language model. If you're making an AI search and summary, always get the AI to cite its sources to say what specific bits of information in the context generated the summary, so that the user could first audit the AI and see if anything was malicious, or even whether the application was just hallucinating. In short, right now we should be building applications to assist users and to boost their productivity, but we shouldn't really be making applications that do things to users without oversight and without consent. We're still working out the security implications here, and that's the best way I can think of to limit our risk. Thank you. I'm Asil Khan. You can reach me on LinkedIn, or I'm also on the Fediverse at asil@infosec.exchange. Are there any questions?
Thank you, Asil. Very interesting topic and very nice presentation. Well done, thanks. So any question?
Maybe one.
Yeah, go
Hi,
on.
guys. So couldn't follow the entire thing. So maybe you already explained that. I noticed that you posted, like you showed us like a way to use the AI to facilitate attacks, of course. Did you have any experience on how to tweak the AI responses, or like use it in a way to defend, like the opposite? Like we saw the example of an injection. Like you ask the ChatGPT to write I don't know, a DOM injection, and you get it and you use it. Did you play with it to get I don't know, the opposite? Given a faulty code suggests me what should I do to fix it? Like, how can I prevent this?
So, sorry, you're asking in the context of can you train an LLM to predict whether a given input is harmful, whether to predict if something's an attack? Or are you asking it, or whether you can predict and audit bugs in code?
I would say if I can ask ChatGPT to provide me with a payload to execute DOM injection on XSS or anything as SQLi, and I will need to provide some information about the specifics of that SQLi or payload, so that ChatGPT will be telling me, use this piece of code inside your delivery system, and that will eventually work. Like, did you ever try to use it in the opposite way? Given I know this piece of code has a DOM injection or a SQLi, can you suggest me the same code base, the same logic? Can you ChatGPT reflect to me piece of code that doesn't contain a SQL injection, for example, and and fixes the problem?
I believe you can certainly do that. You can certainly get an AI to improve your code. I believe Microsoft is doing a similar thing with their security copilot, where it takes the context of someone's code base and generates some advice to improve the security posture of that code base. So I believe you can do that. In the case of if you're asking, can ChatGPT be able to protect against a prompt injection attack by training an AI to detect whether a particular instruction is harmful? That is actually a lot harder, because it's possible in that case to get the first watchdog model to generate an attack against the second application AI model.
Interesting. Thank you.
So there's a question in the chat.
Yep, let me just pull it up.
I can read it for you. What were some of the one of the challenges that you faced when integrating LLM or more generic AI in Atlassian software?
Some of the...
You mean like security challenges, Peter, or?
Yeah, specifically security challenges, some of the sort of potential attacks that you touched on today, like how did you try to prevent that in Atlassian? Or if you can't talk about that specifically, how would you suggest others to sort of deal with that? Like, I like the presentation, it's very extensive. Just trying to get sort of more like an hands-on experience example here, if you're able to share that today.
I can't speak to like internal security challenges at Atlassian, but for one thing, it is quite difficult to get an LLM to perform an action that in an application quite a lot harder to program something in natural language than it is to program something in Java or Python or other code. There's a few ways that you can get a reasonable output from ChatGPT integrated in an application. The first method is to be very specific and explicit with your communications. Another way is to use what's called few-shot learning, which is to provide a example input that a user might give, and then example output that the LLM should give in that case in the system prompt itself. So ChatGPT can then use those few shot examples to provide better context for its output. Those examples could also be potentially malicious, where if you're building out a content moderator, you can give an example of a message that shouldn't be allowed and how the AI should respond. We've done similar in natural language search, where we've given examples of queries that the AI should produce, a JQL that the AI should produce, and examples where it would go beyond its privilege, so that can stop itself and not generate text to that point. But from a security perspective, the best security advice I can give is to validate the output, because there's always potential for ChatGPT to either go off the beaten path and generate something unintentional, or to be co-opted by a user and create some malicious output. Does that answer your question?
Yeah, absolutely. Thanks for that. So I guess like the ChatGPT's output, for instance, should be considered sort of untrusted input to the application. You sort of validate that as how you would normally do for real user input then.
Definitely. An LLM's output should always be treated as potentially malicious.
Awesome, thanks.
I have a question as well, and it might be early days for this. Are you aware of any tooling or anyone who's kind of working on detecting these issues kind of successfully or accurately?
I'm not aware of anything that had any level of success, because like the difference between a classical injection attack, like a SQL injection attack or a cross-site scripting attack, is the attack has to have a very specific structure. It has to be SQL code. It has to be JavaScript. With a prompt injection attack, the attack just has to be words. Like, it has to be English. It's very easy to disguise an attacker's intentions. So while there's been attempts at catching whether a particular string is a prompt injection attack or not, they've had limited success so far.
Thank you.
Sorry, Sayed, did you put a question in the chat?
No, I think it is related to some discussions around, having AI into some security tools like SneakCode and SimGraph, and the NCC research on that.
Oh yeah. Of course, yeah. We're nowhere near the stage where an AI can replace code review.
Well, actually, I'm actually planning to
I think it probably
have a project.
if the LLM is actually based on, because LLM is currently just doing based on like our normal normal data. Like it's not actually going directly. The LLM is actually not a security specific thing, and it's probably the same thing with the what do you call it, prompt injection. I mean, we don't have enough data or ability to figure out if a prompt is actually malicious or not. So we can't just really, like, either you need a sentiment analysis or some other kind of engine in front of it to actually figure out if something is malicious or not, or you need to train an LLM based on, I don't know, there's only maybe 100 examples or 1,000 examples. If you have a million examples of bad data, things like that, so maybe it will work out. But that's just my opinion. Sorry. And sorry for the noise in the background of the bus.
Yeah, to the point, to Farzad, sorry, Farouk point. What we are trying to achieve here in Italy is actually having natural language system to use a bunch of data set that we have already trained to create a model. Then feed basically use it to create a model, then feed the data set plus stuff that has not been audited yet to the same model and run some experiments to then evolve the model and eventually see if we can achieve anything decent. And if we get there, eventually use it in our pipelines to minimize the false positives. But yeah, we are still a bit. It's early days, but I think we can achieve that. We are already doing some experimenting in that sense to use the AI. Sorry.
Sounds like interesting work.
Any other question or comment?
Sorry, I was dying. So we'll say we are achieving some good results using AI in this way. So feeding some data set to create a model with chats, like support chats. And we see that there is a potential there. But yeah, it's a long way.
Yeah.
Nice presentation.
Thank you. Sounds like interesting work. From my experience, from what I've seen, and there are situations where AIs would really help users, in this case, boost the productivity or look at some, in the case of reviewing code, look at some false positives, try and improve the output of some tools, but I don't believe we're at the stage where they can actually replace a human user, just to augment them.
Yes, but low-hanging fruits maybe are in reach.
Oh, definitely.
I think it's actually not to replace the human user, just to make the human life a little bit easier so that you can actually fire 3 of your 10 employees.
Yes.
Thank you very much. That's actually a very good presentation. Sorry, I'm just cutting in a lot, but thank you very much. Appreciate it.
Thank you. And message me on LinkedIn or Mastodon if you want to get political. But I don't think right here is the best we need to talk about that.
Great stuff. Last call for questions. Nice. Yeah, thanks a lot, Asil. Very nice presentation, and I'm sure everyone enjoyed it as much as I did. And yeah, thanks everyone for joining and contributing to the discussions. And I guess that's it. So Scott, do we have anything else to talk about or chat about?
No, the only thing is we have another meetup we're planning in, I think, first week of August, and that will be hybrid. It'll be in a Sydney location and online. More news to come on that, but that's all. So thank you, everybody. Thanks for joining.
Thank you. The
Thank you,
presentation will
Scott.
be shared on our YouTube channel, by the way, if anyone missed part of it. Cool.
Thank you.
Have a good day.
Thank you.
Bye.
Thank
Thank
you.
you, Scott and Sarah,
Yeah.
for setting this up, and thanks everyone for joining in.
Cool.
See you later. Ciao.
Thank you, Sia.